Alright guys, today's goal, the learner will understand the difference between exponential growth and decay. Exponential functions is an equation in two variables that will be written in the form y equals a times b to the x. See how the variable is moved into the exponent? That's why it's called an exponential function. Are the following equations exponential? If so, identify a and b. So if we look at the first one here, yes, it is. A and B, well, I don't see that A there. That means A is 1, B is 3. 2. Is it exponential? Well, the variable is in the exponent, so yes. A is -2, B is 1/2. Okay. Y equals 3x plus 4. Well, that reminds me of y equals mx plus b. What type of equation is this? It's a linear equation, so the answer is no. Alright, here are some key things. Exponential growth. B is greater than 1. Had nothing to do with A. If B is greater than 1, it's exponential growth. So I look at this one. B is 3, so growth. Exponential decay. B is between greater than 0, less than 1. 1/2, so there's a good example of decay. So are the following exponential growth or decay? So go ahead and press pause. Try to answer all three. Alright, so hopefully you did. So I look. B, 1/3. Well, since B is 1/3, it is decay. Next one here, B is 2. That means growth. Because B is 2. Well, B is 2, not capital B. 6. Well, B is 5/2. That's like 2.5. Isn't that still greater than 1? So that is growth. Okay? So there's just being able to identify. So let's move on. Next step here, guys. Make a table of values and graph it. Okay. Always use these. Just find those 5 points. So I take and I substitute in the -2. 3 to the -2 is 1/9. 3 to the -1 is 1/3. 3 to the 0, what's anything to the 0? 1. 3 to the first, 3. 2 to the 3 to the second, 9. So graph now. So you go -2, 1/9, so it'll be just above the 0. -1, 1/3, just a little bit above that. 0, 1, 1, 3, 2, 9. Notice how I never had the line go below 0 or equal 0. Your calculator might tell you it's 0, but if you did like 3 to the -8th, that's just 1 over 3 to the 8th. Would that equal 0? No. So they're never gonna cross or equal to 0 for these. Okay. See how as we read our graph left to right, it starts off. Oh, whoops! Eraser. Hold on. I meant to hit the highlight. It starts off really, really, really slow, and then as the numbers start to get bigger, it shoots up exponentially. That's why it's called exponential growth. Left to right, it goes up. Okay? So let's take a look at another one. Exponential growth. So I see that A is 4 and B is 1/2. So that means they're going to be due decay. So now we'll get to see what the decay looks like. So first thing I would do, -2, -1, 0, 1, 2. Plug them in. Well, that would be 4 times 4, so 16. Plug in the -1, you get 8. Plug in the 0, you'd get 4, because watch. What's anything to the 0 power 1? 4 times 1, 4. Plug in 1, you get 2. Plug in 2, you get 1. Okay, so -216, that's going to be way up and off, so go -1, 8, so 1, 2, 3, 4, 5, 6, 7, 8. Zero, 4, so 0, 1, 2, 3, 4. 1, 2, 2, 1. If I plugged in 3, I'd get 1/2. It's just going to keep getting smaller and smaller. But again, it's never going to equal 0. So look at the difference here. As we read left to right, you start high and then get low quick. So exponential decay. So let's go. So here's your problem. Make the table. Remember, always use these values. Plug those in, make the graph, bring it on in tomorrow. See you guys tomorrow.